So once you've got all of your data organized and labeled and you've made sure that they're measured and reported the way that you want them to be reported, we can start getting into the analysis, and we can finally start looking at the extent to which our variables are related. So there's just a few commands that I really want to share with you guys to get you started. We're going to learn more over the next couple weeks in class, but I'm just going to show you the basics today. So the first command that's really helpful is sum or summarize. And we can click over any variable, and this is just going to give us a lot of descriptive statistics about our variables. So let's do percent of the population age 65 and older. We can click this down here, and then we can hit enter. This gives us a lot of really great information. Obviously, this is going to be the case for all of our variables. We have 50 observations because we have 50 states in our analysis. We see that the mean is 16. So on average, this is telling us that on average, states have about 16% of the population is age 65 and older. We can see that the standard deviation is 1.78, and that variable ranges from a minimum value of 11% to a maximum value of 20%. So this is really helpful in just getting an idea of how the data is distributed. Is there a lot of variance or is there a small amount of variance? If you want to see if your data fits to that normal distribution curve, we can also use the command histogram, or HIST for short, and we can put our variable over here, and we can see whether that data is normally distributed. And as we know, almost all data, natural phenomenon, fit to this normal distribution. This tendency to fall around the mean is evident in almost everything. We could put up all of the different variables and you'll see observations are clustered to the mean, with less observations in the left-hand tail and less observations in the right-hand tail. So this is a really good sign that our data is normally distributed. This might be something that you want to include in your research paper. When I come across graphs that I really want to include in my analysis, one thing that you can do is you can just really simply click this copy button, which is going to copy the graph. You can open a Word document and you can just Control V or right click and paste. And you're going to have all of the graphs that you create really easily ready to go right here. So one thing I recommend is that you just, anytime you copy a graph that you really like over into a separate Word document, something that you want to include in your research paper later, just go ahead and give it a title. So we've created our little title for our figure, and we can click down here to move on. And this is just a document that we're going to have open to, put over any graphs or tables that we find really interesting. So let's minimize that for now and get rid of this. And like I said, the normal distribution is truly a wonderful thing. We can create histograms of all of our continuous variables or our ratio variables, and we're going to see time and time again that they're going to fall to this normal distribution. If your variables don't fall to the normal distribution, it's something that you need to write about in your paper, and something we can discuss how to handle that later. But otherwise, it's pretty phenomenal. Let's do one more. Percent of the state legislature controlled by the Republican Party. Yeah, I mean, again, we see a little bit of skewness, right? We've got a tail that goes more to the left than it does to the right, but still pretty incredible, the power of the normal distribution. Okay, so the first command that I really want to talk about is tab or tabulate. So tab is really great because it's just going to, again, I apologize for the cat who is locked in my office, knocking things off my desk because I'm not paying attention to him. But tabulate is really great because it's just going to show us not only the frequency distribution for the different outcomes of the variable, but we can also add two different variables into this command to create something called a cross-tabulation. So first I'm going to show you what tabulate looks like just with one variable. So I think we already did this. If we were to just tabulate the South, we see that we have 39 observations in the non-South, or 39 states, and then we have 11 observations or 11 states that are in the South. But let's say that we wanted to combine this with another variable. Let's just do the dependent variable. Any of these could theoretically be dependent variables, but let's stick with the South and our campus guns variable. So we can tabulate, we're going to start with campus guns first, because that's our dependent variable. And you'll notice that the graphs make it a little easier when you start with the dependent variable. And then we'll put the South over here. We'll hit enter. So this is what we call a cross-tabulation. And generally, research papers in this class have a ton of cross-tabulation. So you want to take your dependent variable, the thing you're trying to explain, and then show with just a simple cross-tabulation how the data is distributed. So here we've got allowed by law, which is the most lenient type of law you can have. Faculty, staff, students, everybody can carry a gun on campus, anywhere on campus, totally allowed by law. And then we've got totally prohibited by law. So we can see the distribution of states and how they fall into these categories based upon whether they're in the South or whether they're in the non-South. And based upon the reading that we did from, the article that analyzed this data, we had a hypothesis that states in the South were probably more likely to allow concealed carry by everyone, everywhere on campus, as a function of, Southern culture and Southern politics. We expect that Southern states will be more likely to pass laws in these categories, while states that are not in the South might be more likely to pass laws, in these areas. And that's kind of exactly what we see. That hypothesis is a little bit confirmed here. We see that there's a lot of numbers here in the non-South, which kind of goes with our hypothesis that non-South states will be more restrictive of campus carry. And then we see that out of our 11 states, we see that most of them are actually up here, which is the, totally allowed by law. So this is some really great preliminary evidence for our hypothesis. But this is kind of hard to visualize, and at least in the state of how this is currently displayed, we don't have any level of statistical confidence over the extent to which we can reject the null hypothesis that region has anything to do with the likelihood of a state passing one of these types of laws. So the first thing I want to do is let's create a graphic that can kind of help us visualize what's going on here. So if you just want to create a bar graph that has just that reports the simple count or the frequency of observations by specific categories, I'll show you a really quick way to do that. First, we tell Stata that we want to create a graph bar by saying graph bar. It's pretty intuitive, and we're going to tell it in parentheses, just report the count or the frequency or the number of observations that fall into each of the categories. And then you just specify those categories with a comma. And you tell Stata the two variables you want it to consider. So we're going to say we want this to be over. So essentially, we just want Stata to report a graph that groups the data by the policy, which is here, and groups the data by the region, the South. So these are the two variables that we care about. We hit enter. And this is pretty promising, but we have got a lot of garbage down here that makes this really hard to interpret. And luckily, the graph editor in Stata is really helpful and can help us turn this nightmare of a graph into something really easy to interpret. So if this happens to you, all you have to do is simply click the graph editor, and we're just going to click these labels that are all jumbled up. And we're going to do two things. We're going to ask it to make the labels a little bit smaller. And we're also going to ask it to report the labels at a 45-degree angle. And ta-da! This is really great. So now we've got a visual representation of kind of the linear, almost linear relationship here between non-South states and the states that are in the South. So we see that most states that are not in the South are either prohibiting concealed carry on college campuses, or they're letting colleges decide what they want their policy to be. And on the other hand, with the South, we see that, the plurality of states in the South are either allowing complete unrestricted concealed carry on college campuses, or they're allowed on campus but only in locked cars. So again, this is some pretty good evidence that there's a relationship here. We see more non-Southern states here, and we see more Southern states here. But again, we still haven't answered that question of statistical significance. So for now, what we might want to do is say, we really like this graph. We want to copy this. And then we've got our second graph. So you can put as many graphs as you want in your research paper, as few as you like. I think we can make the cutoff very clearly at 10. You don't need to create a graph for every single variable that's in your research paper, but things that are really getting to the core of what you're interested in. You've got a primary independent variable, the thing that you think is going to do most of the explaining of the dependent variable. You can certainly graph that in a variety of ways, and save those graphs here in an extra document while you're analyzing your data in Stata, and certainly include these in your research paper. So remember, we've created some bar graphs here, and that's because we have a dichotomous variable and a categorical variable. We're going to use, if we have two continuous variables, we'll use scatterplots, which are a lot cooler. But just remember, the type of graph that you use is dependent upon the level of measurement. So far, we've just been talking about different things that you can do with two categorical variables. So we'll put this down. We'll get rid of this for now. So the last thing that we were talking about is the level of statistical significance between these two variables. What level of confidence do we have that we can reject the null hypothesis and argue that there is in fact a statistically significant relationship between the type of law that these states adopt and their regionality, whether they're in the South or the non-South? Can we make a empirical argument that there is something special about the South that has an impact on what type of policy is going to be adopted? And to do this, we can do something called a t-test. And the command for that is really simple. Essentially, you type in t-test, which is just going to test the difference of means. So we've actually done this in class. So this is going to do all of the math for us. We're going to do a difference of means test. We want that variable to be campus guns. So technically, t-tests should only be performed on continuous data. But we're just going to assume, this is ordinal, so it is kind of continuous. There's not a whole lot of categories, but your main dependent variable has to either be ordinal or continuous, ratio or interval, for you to conduct a t-test. It won't work with two dichotomous variables, for example, but your main independent variable of interest has to be dichotomous because we're comparing two group means. So we're going to test the means of campus gun policy, and we're going to hit comma, and then we have to tell Stata what our group variable is. So this is where your dichotomous variable goes. And so we put South in parentheses because this is our dichotomous variable, and then we hit enter. So what we're seeing here is the difference of means on the dependent variable between the non-South and the South. So we can see that the non-South has a mean of about 3.6, and the South has a mean of about 2.36 on this variable. So this might be a little difficult to interpret. You might forget, well, did the 5 represent really restrictive, and was 1, did that mean that they could allow college concealed carry on college campuses everywhere. If you ever get stuck, you can just code book that variable again. And so we're going to remind ourselves that values closer to 1, this means that you can carry a gun anywhere on campus. And values closer to 5, this means that you cannot. It's totally prohibited by law. So going back to that hypothesis, we would expect the mean on this variable among southern states to be really close to 1, and we would expect the mean in non-southern states to be closer to here. That's our hypothesis. And so when we look up here at our t-test results, we see that that's confirmed, that the non-South has a much higher mean, a much higher average on this variable, and it's in the anticipated direction. And what we have to look at to determine how confident we are in our results are these areas right here. So this is our left tail test, and then this is our right tail test. Or I think I might have said that backwards. But at any rate, these are the alphas, our levels of confidence. And you can see there's big T is less than little t. So that's testing the hypothesis that this is less than this. We know that that's certainly not the case. That's not the direction that we're expecting the variable to go. What we think is that this is definitely, little t is going to be much lower than the big T. So we want to look at this tail test over here. What is the probability that this mean is bigger than this mean? And so we see that our alpha here is 0.0028. And remember, all we have to do is take the inverse of this, and that tells us how confident we are in our results. So we could just simply display, if we couldn't do that math off the top of our head, display will let you use Stata like a calculator. So we take our probability of 1, and we can just subtract this alpha right here, 0.0028. What this is telling us, here's the proportion, but if we just move the decimal spot over twice, we are 99.72% confident that this mean is significantly lower than this mean. So we have 99.72% confidence that South and that the region is playing a significant role in which policy is adopted by the state. And as you might have gathered, these are the inverse of each other. Okay, so if you have a significant p-value over here, and again, what we're looking for is we want this figure to be somewhere under 0.05, because the inverse of 0.05 would be 0.95, meaning that we're 95% confidence in our results. So you want one of these. Ideally, they're going to go in the expected direction, but you want one of these to be really, 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 really small. And the smaller that these alphas are, the higher your confidence in those results. So I hope that that makes sense. And we will continue to do more t-tests and things like this in class, but this should all be pretty much a refresher based upon the things we've been doing in the last few weeks of the class. So we've got significant evidence here that's, kind of validates our hypothesis and at least rejects the null hypothesis completely. So a good thing to do here is that you could just kind of, you could report these means, in a table or something like that, but you would just want to note these are how many observations were in each category. These were the means of those categories, and this is the level of confidence we have in rejecting the null hypothesis that there's no relationship. So if you're working with two categorical variables, and one of them is definitely dichotomous and you want to compare the mean between one group and another group, t-tests are a really phenomenal approach that you will want to use in your research papers. So next, let's start working with some more continuous variables, because I think a lot of people in their research papers have a lot of continuous variables. So let's say we wanted to examine the relationship between, let's stick with campus guns. Let's say we wanted to tab campus guns and we wanted a continuous variable. So maybe % of the state legislature that's controlled by Republicans. Now, what I'll show you is that if we tab this, we're going to get an error. Too many values. And remember, you can really only use tab for 2 categorical variables. The percent GOP in the state legislature is continuous. We can summarize this variable to get an idea of its range. Now we have 49 observations. This is because Nebraska has a nonpartisan legislature. So we actually don't know the partisanship of the members of Congress or the members of the state legislature because they don't have a party affiliation, but that's okay. Anyone who uses this variable will only have 49 observations. But we can see there's some fantastic variance here. Look, the mean is 56. So on average, Republicans control about 56% of all state legislatures. There's a huge standard deviation of 18.69. And the standard deviation, it's so large, it's helping us understand the incredible spread on this variable. State legislatures can have anywhere from 6% of their members being Republican all the way to 86%. And that's incredible. And if you're interested in kind of analyzing this, I think something you can do is list state and then GOP. What is it? PCT, GOP. And the great thing about state is that we don't have to type the entire variable. You know, if there's no other variable that shares like the first 4 letters, we can just type enough letters to let Stata know that we could only be talking about this specific variable. So we can hit enter. And we can see all of this information. Another thing that we could do is like, if we just wanted to quickly understand what was the low and what was the high, we could sort percent GOP. So now all of our data is sorted from, instead of being sorted by state, it's now sorted on this specific variable. So we could find this variable here. Now you can see that it's all of our data is now no longer in alphabetical order by state, but instead from lowest to highest just on this variable. So Hawaii is our state with very, very few Republicans in the state legislature. And we can scroll all the way up. What do you guys think it is? What state could it possibly be? Oh, Wyoming. That makes sense. So we've got a really cool idea of like how the states are distributed. It's interesting to see all these Souths clustered here in this high range of this variable. So those are just a few little things you can do if you want to try to isolate some cases, see what's going on in your data. Sort is a really good one. List is a really good one. We can also add conditional commands on this. So we could say list state and the percent GOP if percent GOP is greater than 70. Say we just wanted a snapshot at a few of the cases. This is only going to report states and this variable if it's over 70 or not. And we could do the same thing. Say we wanted to know what states had, less than 15%. And so we can see these states here. So lots of really cool stuff you can do with the if command on just about any Stata command there is. So getting back to the point, we were interested in tabulating these 2 variables, I think. That one and this one. And it said too many, oops. Well, now it works when I do it the other way. We see how complicated this is. Like this is the variable that we wanted to tab, campus guns and percent of the state legislature. What this is doing is that this is giving us every outcome. So this is every state based upon the percentage of the state legislature that's Republican. And then this is giving us the categories. But this is almost impossible to decipher. So we don't want to use tab. We don't want to use tab ever when we've got at least one continuous variable in there. So something that's really powerful to look at instead are pairwise correlation coefficients. So we're just going to type in PWCORR, and this is just going to report a really simple correlation coefficient. Remember, positive, really large positive values tell us that there's a strong positive relationship. Really low or high negative numbers show that there's a negative relationship there. And remember, the correlation coefficients range anywhere from -1 to +1. And if we have a correlation coefficient that's sitting right around 0, that's telling us that there's not very much of a relationship at all between our two variables. So we can do our command for performing some correlation coefficients, and we can put campus guns and %GOP state legislature, and we hit enter. So remember, this correlation coefficient maxes out at -1. It also maxes out at +1. That is the range. And this is pretty close to, halfway before the entire range of possibilities maxes out. So we've got a really strong negative correlation coefficient here. And what this is telling us is that as this variable increases, this variable is decreasing. And remember, anytime you need to refresh your memory, high values mean it's completely prohibited by law. And based upon everything that we know about campus carry, we expect Republican state legislatures to allow by law. So the way that this variable is coded is that we would expect more Democratic state legislatures to adopt these policies. More Republican legislatures, we expect them to pick up these policies. So as this variable increases, I hope that makes sense to everyone, as the number of Republicans in the state legislature increases, we're actually expecting the observations to be clustered down here, lower values. So that's why it's a negative relationship. And if we wanted to graph this relationship, before I do that, so we've got a really strong correlation coefficient here, but we want to know, is it statistically significant? How much confidence do we have that these variables are in fact related? So we can hit page up twice or 3 times to go to that previous command. And now we're going to type the option sig for significance. And this is just going to report a coefficient with our level of confidence in the relationship between these two variables. And again, the lower the number, the better. So this is our coefficient here, and it's 0.0009. So again, if you had a hard time doing that math, all we have to do is subtract that from 1. And we are 99.91% confident that there is a relationship between these two variables, and it's a negative relationship. So this little tiny table is telling us a ton of information about how these variables are related to each other. So this is certainly something that you'd want to put in your paper. And again, if you're more of a visual person and a visual representation of this data would make more sense to you, I'm going to show you just a really simple graph command that you could do. So we're putting our categorical variable at the end because we want to graph our continuous information based upon categories. That's what over is telling us. So we just hit enter. And again, we've got some issues here. So we're just going to go to our graph editor. We're going to ask to please make these a little bit smaller and please report. No, actually, we don't have to do a 45-degree angle. That actually looks pretty good. So here we can see the mean of the state legislature that's controlled by Republicans. And this is really telling. So when about 70% of the state legislature is controlled by Republicans, we're getting an allowed by law policy outcome. On the other hand, states that prohibit concealed carry on college campuses, on average, they only have about 45 to 50% of the state legislature controlled by Republicans. It's very close to the mean. So we see a nice decline here, a negative relationship that shows as this variable increases, this variable is decreasing. So I would totally copy this and I would go to my Word document, and that is a great one to include in the research paper. Again, don't forget, sometimes your variables might not have these nice labels, and it might be kind of confusing what they stand for. So we just want to make sure we remember figure 3 is so the PWCORR, the pairwise correlation, or just the correlation coefficient, is super powerful. And you can use this command for any two sets of variables. In fact, we can actually do this with all of our variables to create something called a correlation matrix. And this lets us know how correlated. Let me run that again so it's more cohesive. I have too many variables. Let me just get rid of a few of these. And so that way they're not running over into a second line or anything like that. We've just got a really simple correlation matrix that shows the correlation coefficient for every single pairing of observations. And obviously, percent bachelor's degree is perfectly correlated with percent bachelor's degree. That makes sense. If we were wanting to see how related is this variable to this variable, it's the same exact variable. So of course it has a perfect correlation coefficient of 1. If any of your variables down here have a -1 or a +1 perfect correlation, that is so statistically unlikely. It usually means that you have an error in your data. So this is actually something that's really good to run just to get an idea of how closely your variables are. And you might actually find, let's see. Let's put our dependent variable in here. Let's see, campus guns. And let's get rid of, let's change this to percent minority. Oops, I mistyped it. Campus guns. So here's our dependent variable, right? And we can kind of just look and see right off the bat how related are our variables just with this dependent variable. And we've got a pretty good one here. Percent unemployment 0.2767. That's actually pretty strong, and maybe this is something that we wanted to control for and we didn't think that it was going to be related, but this is showing us, oh, I might want to look into this variable in a little bit more detail because it's got a decently positive correlation coefficient with my dependent variable. So that might be something you want to consider. Here's some other really cool ones that make sense. Median income has a super strong correlation with percent bachelor's degree, and that makes sense, right? As the number of people in your state with a bachelor's degree, as they become more educated, median income also increases. So that's a super high correlation coefficient. And one thing that I want to show you is that if you have two continuous variables, you can make some of the coolest graphs, some of the coolest inferences. The best way to graph two continuous variables is with something called scatterplot. So we can just hit scatter, and let's say we want to do percent, let's do median income and percent with a bachelor's degree. And look at this incredible positive trend that we have here. We can see that for every unit increase, every 1% increase of the population with a bachelor's degree, we're seeing a very strong positive increase in median income as well. So remember, each of these dots represent the states. There's several cool things that we could do here. We could redo this scatter plot with the option marker label and tell it that we want it to label each of those little dots with our state variable. Let's actually change it to abbreviation so it's not so crazy looking. So remember, in our data editor, we have our abbreviation, and it's okay that these are string. They don't have to be blue. It's totally okay for these variables to stay in string format. But we just applied this abbreviation to the marker label, and so now we can see all of our states and who are doing the worst with educating their population and have the lowest median income. So this is a really awesome graph that I would totally recommend. If this was something that you found in your data analysis, I would definitely include this in your research paper. There's just a few more things I want to show you that are really fun with scatter plots, just because they're so informative and the linear relationships are always so much fun to analyze. If we wanted to fit kind of a directional line through our data and also apply confidence intervals to that line, here's a really cool command that you can use. So basically what I've done here is I'm telling Stata I want you to overlay two graphs on top of each other. So I'm saying graph two-way, and this lfit ci, that just means line fit confidence interval, and I'm telling it to do that with these two variables. And I'm also saying, can you please add a scatter plot on top of this line? And so we end up with something like this. So I've got really tiny confidence intervals. This is great. This means that I'm explaining a lot of the variance here, and you can just see the little dots running through the plane, and this is my linear projection of how related these two variables are. There's really no limit to the things that you could do here. You could even get super crazy with it, and maybe you wanted to also incorporate, you wanted to display whether the state was south or whether it was non-south. So we could actually type over here, if south equals 0, and we can copy this and we can paste this. If south equals 1, but we need to tell them that we want a different color. This is a little advanced and you don't have to worry about this, but anyone who might have coding experience and this isn't super overwhelming, this is just a little thing that you can try out. It's certainly not required. Southern states are always blue, right? Or I'm sorry, non-south states are always blue. And then this is our south equals 1. So we're going to say we want this M color to be red. I think I typed this right. So cool. We could just, so now we've got our southern states in red, our non-south states in blue. We can, not surprisingly, our southern states are kind of clustered here towards the bottom. Again, you're going to want to make this clear for your reader. So before you save these, you're just going to want to say that these are non-south. You're going to want to say that these are the south. You want the reader to, you have to assume the reader knows nothing about your research paper and that they're going to take one look at this graph and they're going to know exactly it is what you're trying to communicate. So we've got this. We also don't have a y-axis title here, which is kind of problematic. All we have to do is click on y-axis title and say that this is median income. And then we've got our little label right here. And then we're going to copy that and go back to our Word document and paste. And what is this? This is figure 4, I think, if we're up to figure 4 yet. And it's basically, right, this is like a little too basic. I'd want you to say bachelor's degree, median income by South and non-South, but I'm just kind of writing it in there for the purposes of the example. So we've already, we've been doing this for just a little bit. We've already got some really great graphs, plotting some relationships. This is exactly what we're going to do in class on Thursday. We're going to keep working with this data to get you comfortable with the commands and graphing and things like that. And then if we have time, you're going to import your own data into Stata and then start testing some of these relationships yourself. So I think we've got a lot of really great commands for you to start working with. So I'm going to try and wrap it up here. We've covered a lot of different commands. The thing to be most aware of is the type of command that you use. It really matters what that level of measurement is for that variable. So again, when you're using tab, you really shouldn't be dealing with any continuous variables, or you're going to get something horrific like this table that doesn't make any sense at all. So we definitely don't want that. Scatterplots are really great for two continuous measures. They show us, well, it's on the other page, but they show us how as one variable increases, the other one increases or decreases. So really steep lines mean a really strong positive relationship, and the flatter or more horizontal the line is, the less of a less strong relationship you have there. And then we've also covered lots of different graphs using graph bar for graphing our categorical variables. So this is just the introduction. Over the next 2 weeks, we're going to learn even more and more commands. So I hope that you found this video helpful. We're going to have a lot of fun in the lab working with this data as well as your data. We're going to continue learning commands. So I'm going to go ahead and wrap this video up here. That's it for this week. Thanks for watching, and I'll see you guys on Thursday.